Hello. Today I'll be teaching you how to do question 13 from lesson 3.6 of Energizing Physics. So in question 13, you're given that a person is pulling a box, right? And so the box has 100, the force of friction between the box and ground has a strength of 150 newtons. You're also given that the person pulls with variable force in between these times, in between the times that she's pulling. From 0 to 2 seconds, she pulls with 250 newtons of force. From 2 to 3 seconds, she only pulls with 150 newtons of force. From 3 to 4 seconds, she pulls with 200 newtons of force. And finally, from 4 to 5 seconds, she pulls with 150 newtons of force. And what you're trying to find is the ranking of the speeds of the box over time. And so the important things to remember are that energy, E1 plus work equals E2. And that kinetic energy is equal to 1/2 mv squared, and that work is equal to force times net force times displacement, and finally net force is equal to the sum of all the forces, or in this case it will be force pull minus force friction. Alright, and so when solving this, we first have to solve for the net force that's happening in between all these time periods. And so the net force from 0 to 2 seconds is equal to 250 minus 150 newtons, which is equal to 100 newtons. We're also given that we can also solve for from 2 to 3 seconds, which is 150 minus 150, or 0 newtons. From 3 to 4 seconds, it's 200 minus 150 newtons, or 50 newtons. And finally, from 4 to 5 seconds, the net force is 0. And so now that we have that, we next need to solve for the work done over this time. And so the actual number itself doesn't matter, but the important thing is whether or not the work is positive or whether it's 0. And so since in between 2 and 3 seconds and in between 4 and 5 seconds, the net, it says F pull, it should be F net. But yeah, since in between 2 and 3 seconds and 4 and 5 seconds, the net force is 0, that means the work during this time is going to be 0 as well. And since the net force between 0 and 2 seconds and between 3 and 4 seconds has a positive value, the work done is going to be some positive value. Right? And so since the box never slows down over this time, because you never take away energy from the box, the time at 0 seconds is going to be the slowest. And so from 0 to 1 seconds, the work that is done is positive, which means that you're adding KE from point 1 to point 2, well, from 0 seconds to 1 second. And so as a result, the speed at 1 will be faster than the speed at 0. The same thing happens from 1 to 2 seconds, where it gets faster at 2 seconds than it is compared to what it is at 1. However, from 2 to 3 seconds, the work done is 0. And so that means that the KE stays the same, and that the speed stays the same at this time too. From 3 to 4 seconds, the work that is done is positive, and so that means that the total energy and the KE increases, and as a result, the speed increases as well. And lastly, from 4 to 5 seconds, the total work that is done is 0, so the speed stays the same. And so as a ranking, we get 0 has the speed at 0 seconds is slowest, followed by speed at 1 second, and then the speed at 2 and 3 seconds are tied, and then that's beaten by the speed at 4 and 5 seconds.